Welcome back to the Art of Math. Today we're going to go over why the square root algorithm works. Specifically, the square root algorithm introduced in video number 15 in the series. This is known as the Vedic Square Root algorithm and has a lot of its roots in India. Alright, so we're going to go over an example really quick as a refresher and then prove why it works. Okay, so let's say we have a number 345,768. The first step is you're going to break the number into groups of 2 digits. So that's why we have these little dotted lines. Now, if there's not an even number of digits, so let's say this 3 is missing, then you would just have this 4 be by itself. So the leftmost digit would be by itself. But if there's 2, then you group them into all in 2s. All right. So first thing we're going to do is take the 34 and see what's the highest number that when squared is still under 34. Or equal to 34, so that would be a 5. So that's why that's a 5. So 5 squared is 25. Subtract them. We're just going over how the algorithm works, and then we'll explain. And by the way, if this is a little too fast, then go and review video number 15. So when you subtract these, you get 9. And now the procedure calls for dropping down the next 2 digits. That's why there's a 5 and 7 here. So now the next step is a little weird, and this is going to be the focus of the proof. So now we're going to take this 957 and do some sort of weird division. So we're going to take our existing answer of 5, we're going to double the 5, that's how we got this 10, 1, 0. And now we're going to put a dash, an underscore and an underscore. And so we're looking for what's the highest digit that I could put here and here. It has to be the same digit. So that 1 0 blank times a blank has to be under 957. So if you try a 9 and 9, that would be 981, which is too high, so that's why this is an 8. So we get 864, we put that here, we subtract them, we get 93, drop down the next 2 digits, 9,368. Now we have our 5 and 8 from the previous steps, so this 8 that we put here goes over here. So now we're going to double 58, that's 116, which shows up here. And now we put a blank and a blank. And so what digit has to go here and here, such that 1,160 something times that same something is equal to or less than 9,368. So that's going to be an 8, which gets us pretty close. So we put that over here, subtract them, get 24. Now there's no more digits, but so at this point we're just going to introduce the decimal point and drop down 2 zeros. So that's how we get 2,400. So now we're going to double 588. That's going to be 1176. 1176 blank times blank. Try and get to 2,400. Well, this is already pretty high. So even if this were a 1, this would be literally 11,761 times 1. So that's too high. So that's why this is a 0. So the 0 goes there. And so on and so forth, and you can keep doing this on if you want to get more and more digits. Now, as you can tell, it's going to get a little more annoying because these numbers are getting larger and larger. Anyway, so that's an example of how it works. Quick refresher. So why does this work? There's kind of two parts to it. So the first easy part to explain is why are we splitting these into groups of 2? So that's not part of this proof on the right. So the reason we're splitting these into groups of 2 is that each time we introduce a new digit, so let's say you have 5, right? Now we added an 8. What is the effect of this 8? You have an extra digit. So now instead of being a 5, this is like a 50 now, a 58. So since you have an extra place value, when you square this number, so just think of the number 50 instead of 58, so it's a little easier. So when you square 50, you get 2,500. So that 1 0, when squared, got you 2 zeros. So that's why in terms of squaring, we're going not by 1 digit as in normal division, but in groups of 2, because when you square things, you're going to move 2 place values at a time. So that's a little bit behind that part of it. Now, the weird part is really this business over here. And to be honest, I didn't even know why this worked for a long time. So let's go into why this works. So let's think of this whole number as our n, that's our number. And x will be our initial approximation. So now, for example, so in our example here, I put a 5, but really this would be a 500. So this would be like, what's the, so for example, if we put 600, 600 is going to be 300 and, let's see, 600 would be 36 and 4 zeros, right? So that'd be 360,000. So 600 would be too large. So that's why we put a 5. So that's our, don't think of this as a 5, think of it as a 500. So that's our initial x. That's like the easy part to see. So down here below, x is the easy part, right? That's what we can pick off right away. We looked at 34 and saw that 5 squared is the best we can do because 6 squared is too high. All right, so that's our initial x. Now what we're going to do, so this is not the proof of the whole thing, this is the proof of every step, this key step. So every time we do one round of this, we're trying to get a little bit closer to our number. So we're going to take our x and we're going to try to add r, like the remainder or the little bit, right? So that r is going to be this 88 point whatever. Now, but in practice, we're not going to have the whole thing, so the r like on one round would be 80, just 80. And then the next round it would be the 8. So each time we're going to add a little bit. So the question is, what's the most we can add, like one digit at a time, to still leave us either equal to or just below the number? That's why this says less than or equal to the square root of the number. So that's what we're trying to find. We're trying to find the best r. So now we're just going to square both sides, expand, and then we're going to subtract the x squared. So we're going to move the x squared over to the right. And now we're going to factor, so these both share an r, so take out the r, and now we get this funny looking thing. Now this may look completely mysterious, but take a look at what this is saying. You have the r and the r, and remember the r is like this new digit, that's like the 8, that's the new digit we keep adding. And then we have the 2x. So if you recall from the left, what do we do with the 5? We doubled it, that's the 10. Here you go, so that's 2x, we're doubling our first digit. And then the blank, so 2x plus the blank, that's your blank, the r, times the same blank. So this is literally analogous to this procedure. So we're saying, what's the highest r I can put, which is what we were doing here, like the 8. If r were 9, then this would work out to be too high. So r would be 8 in this first iteration. So if r is 8, this keeps us just under this. Now, and what is this? That's our number. That 34, ignore the place values for a sec. So that's that 34 minus the first digit that we squared, so that's the 25. So that would be this 9. But remember, now with the place values, it would be 957 because there's more stuff going on. So this is literally the remainder from doing the subtraction. So this would be the 957. So that's why this step works. Now, hopefully that gave you a little bit of an idea. So just by expanding and factoring a little bit, we saw where the doubling and this mysterious r and r came from, this 8 and 8, this little game we're playing. Another way of thinking about this, just so you get the main idea, is simply by expanding x plus y. So if you do x plus y squared, it's x squared plus 2xy plus y squared, but we can rearrange it like this. So we have x squared, and then from the next two terms, we'll just factor out the y. So what is this saying? And this is, keep in mind, this is a little similar to this, very similar. The x is the easy part, the y is the harder part. So x was our 5, we saw that right away, right? So if I give you this huge number, you could say, oh, 500 is pretty, that's like my first guess. It's not 600, it's 500 something. So that's your x. Now you want to know what's the little bit you need to add to actually get that number. So we want the best y. So it would be your 2x, again, this is that same 2x from here, plus y, so our y is the same as this r, that y is that r. So hopefully by looking at these, this gives you a little bit of intuition behind, like, why do we double that 5, why do we double this 58, why do we double the 588, and what's with these little blanks in this little game we're playing. Alright, so hopefully that helps satisfy some of your curiosity. I will see you guys in the next video.